Who here has had to deal with relational database spaghetti? I mean, it looks like a nightmare, right? That's terrible. Oh, well, that actually looks pretty good. It's not quite lunchtime yet, so we'll get through this talk and then we'll get something to eat in a bit. Today we're going to talk about a different way of storing data. Structuring data as normalized is the standard for relational databases, but who wants to be normal? Let's denormalize our data, put it in documents, and get lightning fast reads in our applications. I'm Jesse Hall. I'm a senior developer advocate at MongoDB. You might also know me as codeSTACKr from YouTube. So today we're going to look at the document data model and how it's different from the standard relational model that you may be used to in a SQL database. We're going to look at some trade-offs between normalization and denormalization, and we'll look at relationships, and then data modeling with documents, embedding versus referencing, and how Prisma can help us with this. So back to that relational spaghetti. When we model data in a relational database, something like a SQL Server, Oracle, or Postgres, you go through a process of normalization of data elements, which is by its very nature causes you to separate data into separate tables. And so you're going to end up with something like you see here. And this type of data storage has really been the norm for a very long time, and it still is. But today we're going to talk about a completely different way of storing data. But why has storing data in rows and columns been the prevalent way of storing data? Well, here's the reason. When databases were invented, it was very expensive to store data. The hardware was expensive. In 1956, it cost $9,200 to store 1 megabyte of data. Today, in the year 2022, you can pay as little as a fraction of a cent per megabyte of data. So when normalization was introduced, the most precious resource was disk storage. And as a result, the primary rule was to reduce disk space by never duplicating data. And here's another look at the rapid reduction in data storage costs over time. Edgar Codd introduced the rules of normalization in 1970 when storage was still very expensive. And then around 2007, someone comes along and asks the question, does normalization still make sense? We no longer have the constraints of limiting data that is saved because of financial costs, and this was the birth of MongoDB. And this is a great way of visualizing the difference between storing data in a relational database versus a document database like MongoDB. So in the relational database, if we wanted to store our car, we would separate our car into a tires table, a seats table, an engine parts table, a brakes table, and so on. And then we have to join everything back together when we want to drive the car. Now, has anyone ever said, let's not use the brakes today, we don't need those, or we don't need the tires, or any other piece of the car? No, you need every piece of the car every time you want to drive it. And so all of this has to be joined back together every single time we want to use our car. In a document database like MongoDB, this is how we store our cars. It's all together, ready to go when you need it. So generally in MongoDB, data that is accessed together should be stored together. And if there's one thing that I want you to come away from this talk with, and it's this. This is how we model data in MongoDB. But not all data is created equal. There will be use cases where we don't need all of the data every time. And so we're also going to talk about how MongoDB stores related data in different ways. So let's take a look now at some terminology surrounding MongoDB document databases. So some refer to MongoDB as a NoSQL database, and that gives the impression that SQL is not allowed. But the term actually means not only SQL, and so this isn't really the best way to describe it. Others refer to MongoDB as a schemaless database, and that's not an accurate description either because it does have a flexible schema, and you're encouraged to define a schema for your data, and you can even use schema validation in MongoDB at the database level. And so then others also refer to MongoDB as a non-relational database. And again, this isn't a great description because relational data can be stored in MongoDB, it's just stored differently. And so really the best category to put a document database like MongoDB in is non-tabular. We don't store data in tables with rows and columns. And so it requires a shift in the way you approach storing your data. Normalization of data has been ingrained in us. It's all we know. So storing data in a document database requires a shift in thinking. And so we're going to go from tables of data with relationships to documents of data which can contain embedded data. And these documents use a JSON-like structure. So this document here is the representation of the exact same structure as the tables. And so as you begin to think about the schema for your application's data, ask yourself 4 important questions. What does my app do? Describe its workload. What does my data look like? Identify and model the relationships. How do I access my data? What tooling am I going to use? Hopefully you'll be using Prisma. And how is the end user going to use my app? So apply existing data access patterns here. You may think that your data is unique, and it may be, but the way in which your users access your data is probably not unique. And so there are existing patterns that can help you to model your data. How do we model relationships in MongoDB? A flexible data model means that one document to the next can look completely different in the same collection. And that's okay. It's called polymorphism, not schemaless. You can also store documents that have other documents nested or embedded. You can normalize data if that makes sense for your application through the use of references. And what you really want to focus on, though, is how your application is going to reference or use the data as opposed to how it's stored in the database. How will your users access the data? This is the opposite of how data is modeled in a relational database. In a relational database, we get the data requirements, we model the data, and then we pass that along to the application UI. In MongoDB, we start with the UI UX and ask how will users interact with our data, and then we model the data accordingly. And so this is where the flexible document data model makes sense. You're not constrained to one way of storing data. You can choose to normalize some of the data if that makes sense, embed other data that will be accessed together, or any combination of storage methods that makes sense for your application. So again, data that is accessed together should be stored together. Let's take a look at modeling relationships. These are common relationships no matter what database you're using. We have one-to-one, one-to-many, and many-to-many relationships. So let's take a look at modeling one-to-one relationships. In a traditional tabular method, we would have a movie table, and that could be related to a movie details table by the movie ID. In MongoDB, we could do the exact same thing and have a movie collection and a movie details collection and use the movie ID as a reference. Or if the data is usually accessed together, we could just have one movies collection and embed all of the data there. Now looking at the one-to-many relationships, in a traditional tabular method, we would have a movies table and a cast table, and we can see here that there are many cast members related to a single movie. In MongoDB, we could do that exact same thing and have a movie collection and a cast collection, and the movie ID is a reference to each cast member. Or again, if the data is usually accessed together, we could just have one movies collection and embed all of the data there. You might use embedding to make queries more efficient. Nested arrays give you a great way to model one-to-many relationships. The cast is an array data type. And the benefit of this is that you can use one single query to retrieve all of the data that you need for the application. So now let's look at the many-to-many relationships. In a traditional tabular method, we would have a movies table, a locations table, and a movie locations table. And we can see here that each of these are related to each other and are creating a many-to-many relationship. In MongoDB, we could do the same thing with two collections where the movies collection references the filming locations and the locations collection references the movies where they were filmed. Or again, if this data is usually accessed together, we could just have one movies collection and embed all of the data there. Again, if the data is accessed together, it should be stored together. Next, let's look at embedding versus referencing. We're going to look at some pros and cons between these in MongoDB. So in embedding, when you embed data, you can use a single query to retrieve the data, and this is much more performant. You can also use a single operation to update or delete data, reducing the amount of writes needed. But you will likely have duplication of data and possibly larger documents. But remember that data duplication, though, is not necessarily a bad thing. Depending on the use case, it could actually be more efficient. So with referencing, there is no data duplication. You'll also likely have smaller documents, but you'll need to join data from multiple documents, which will decrease performance because of the extra resources needed. And so again, with document databases, we have the ability to choose how we store our application's data. You should use embedding for data that is accessed together. You're going to get fast reads, but you may get a chance of slower writes if the embedded data is duplicated in other areas of your database. You should use referencing for data that is infrequently accessed together. You're going to get faster writes because you're not duplicating data in this way, but you may get slower reads because we'll have to reference multiple collections to join the data back together. And so you have to decide what is more important for your application. Do you want faster reads or faster writes? Does your data change a lot? You might want to separate that data so that you don't have to update multiple duplicate locations. Or does your data rarely change? You might want to embed that data to get faster reads. And now, how does Prisma help us to store data in a MongoDB database? Well, it's really simple to set up. You're going to add a database underscore URL variable to your environment variable file that references your MongoDB Atlas connection string. And then in your schema.prisma file, set the data source DB provider to MongoDB, and then pass that environment variable for the database URL that you just set. And then you can use embedding by creating types. Here we have a movie model, and this has an ID, a title, a director, runtime, and locations. Now, the locations references a location type. So next we define our location type, which has a country and a city. And this schema is going to result in a movies collection in MongoDB, and the location will be embedded in each document. And Prisma can also help us with references as well. We can use references by using relations between models. So here we again have a movies model, just like before, but this time there is a comments field containing a comment array. And then there is a comment model, which has a relation to the movie by the movie ID. And there's also a relation to the user who made the comment through the user ID. Then we have our user model, and that contains the user info. And this is going to result in 3 collections in MongoDB: a movies collection, comments, and users. So Prisma makes it super easy to set up relational data in MongoDB by either embedding or referencing or any combination. So to recap, we looked at the document data model, normalization versus denormalization, embedding versus referencing, relationships, and how Prisma can help us model embedded and relational documents with ease. Thank you again for your time. I hope you learned something. Be sure to check out the M320 data modeling course on MongoDB University, and we also have several other blog posts on the subject on our Developer Center on mongodb.com. Hello, Prisma Day.
Jesse, this is David.
Hey, David.
We miss you and wish you were here.
So nice.
I'm gonna help with some Q&A time. You have some time for Q&A?
I do. I have plenty of time for you.
Sorry, that was a terrible stuck in a hotel room in New York joke. Jesse, if anyone has a question, we'll get the microphone to you. Who has a question for Jesse? If not, I'm going to ask him questions, and that's not what you want.
I don't want any hard questions.
All right, go ahead. We've got one here. Is it Frederick? All right.
Hi, Jesse. For relational databases, migrations are an important topic, schema migrations. And so I wonder if you can share any stories from users, how they evolved their schemas with Prisma and MongoDB.
Yeah, so migrations is not a thing in a document database. So Because of the flexible schema of MongoDB, it's actually, in my opinion, it's much easier because there are no migrations. Your schema just evolves as you need it, and so you really don't even have to worry about the entire migrations process.
It's scary, right? You'll be okay.
Yeah. Again, like thinking in a document database is completely different from the SQL world. You have to throw everything out the window because it's totally different world.
Any other questions? Thank you, Jesse. Yeah, we got another one for you.
Hi, Jesse. Great talk. I had a question because the relational and embedded difference. I was a bit surprised that you showcased that in the Prisma model, the way you modeled your types in Prisma led to different ways that MongoDB actually organized the data. I thought the purpose of Prisma abstracting this away was that the developer doesn't really need to know the details of this, for example. So in my head, I was kind of confused about it because, like, imagine a developer doesn't know about MongoDB stuff and structure the data in one specific way. They would need some MongoDB specific knowledge in order to structure it in the correct way for read access or something. I was more expecting something like I model my data how I want to, and I do like an annotation quick read or something, and then MongoDB like organizes it according to my needs. I was confused about the tie-in there.
Yeah. The way that it's modeled again is completely different, and so from a relational database world, you're used to normalizing everything and separating everything, and then from the MongoDB perspective, we start with the user experience. How is the user going to access the data? And so think about it in that way. What data does the user need to access on this page versus the next page? And you model your data in that way. And that's how we can decide which pieces of data that we want to embed versus reference. And so it does, again, take a totally different way to think about it. But Prisma does an amazing job of making that super simple and super easy.
Very good. We still have some time. Yeah, go ahead. I think there was one in the back. No, maybe you answered it. Okay. Yeah, go ahead, Pavel. We have a couple more.
Yeah, so, thanks for the talk, first of all. And my question would be like, seems like this non-tabular approach is like very powerful and probably can be used like in many ways and replace tabular approach. But like still, can you come up with some use case where MongoDB wouldn't be like a best solution, and where would you still go for SQL-like solutions? Thanks.
No, I get that question asked a lot, and I know that there are some use cases. And I'm not going to say that MongoDB is the best, or a document database is the best for every single solution, but I can't think of a use case off the top of my head that it wouldn't work for, because there are so many areas that it does work. So.
Yeah, thank you. Yeah, go ahead. One more here.
Thanks. This is actually funny. Yeah. So the only like trap that I discovered so far with the denormalization of the data is that it's very great and performant when you have static data that like doesn't change a lot over time. But when you have dynamically changing data that is expected to change frequently, it's actually troubling in the normalized world, because, for example, we have a profile name that is used in like hundreds of other collections, and when the user updates his profile name, now it's a huge hassle for us as a developer to keep track of every collection, of every use case of that name, and update that. So in that case, we usually currently use referencing and kind of trade off our performance of read queries so that we don't have a hassle of tracking everything. My question would be if a Prisma can actually, or any other like abstraction on top of any NoSQL database, could help solve us that problem and actually track that for us, so we don't have to think as a developers and spaghettify our code to actually do that ourselves.
Mm-hmm. Yeah, no. So again, it takes, there's some give and take there. Do you want really fast reads? Do you want really fast writes? How often does the data change? All the same things that you just said. That's how you would model your data. So if you having to update, like you said, maybe a user profile, that is not something that you would probably want to duplicate too much. And then it comes down to tracking how many things are duplicated. So there's one thing that in MongoDB Atlas, there are triggers. And so you could on write to a certain cluster or a certain collection, you could tell it when this write happens, go ahead and update these other pieces, and that will happen for you automatically on the back end for you. So that's one way to go about it. But then it just, again, it comes back to tracking where is that data duplication and making sure that you've got all of your bases covered. Again, it's case by case basis as to whether you would want to duplicate data or not. Some cases it's much more performant to duplicate the data. Some cases it's not.
I like that one. I learned something. We need to move on. Sorry. Thank you. Jesse, I have a question though.
Sure.
Okay, so I can't make any promises because I don't make the decisions, but I know people. So we wanted you to be here and you couldn't make it. So what if we get together in a beer garden in Berlin sometime next year? What do you think? Would you come and join us then? You want to do this again?
I'll be there.
All right.
Yep,
We would love to have you. Jesse, thank you. Really exceptional talk, and thanks for joining us live. All right.
All right, thank you.